So howdy, my name is Wickersham. I work here in the Department of Animal Science as a ruminant nutritionist. Work mainly on beef cattle nutrition from a research standpoint, and then I also teach both undergraduate and graduate nutrition. And so today what we're going to talk about is a real basic overview of how a ruminant works or how a beef animal works from a nutrient utilization standpoint. And you all should have drawings that you can print and follow along with and draw on or add to as much as you want. So with that, we'll go ahead and get started. So what we have here is basically a cow, and just to start with, we're going to go through and label kind of the important compartments or the important segments of the gastrointestinal tract. And the most important one, or the beginning, is the mouth. And from the mouth, we move to the reticulum and the rumen. So on our cow, we're going to show that as one functional unit because they basically function the same. But if we're making a list of the 4 compartments of the stomach, we have the reticulum, the rumen, the omasum, and the abomasum. And on all the subsequent drawings, we'll label this the rumen, because like we said, the rumen and the reticulum are fairly similar and kind of one compartment separated just by a pillar. This is the abomasum, and we'll talk about what each one does here in a second. This would be the small intestine and the large intestine. And then up here we have the pancreas, the gallbladder, and the liver. Okay, and when we look at the small intestine, it's divided into 3 sections. We have the duodenum, the jejunum, and the ileum. Okay, and we said there are 4 compartments to the stomach: the reticulum, the rumen, and the omasum. The reticulum and the rumen are the site of fermentation. So this is where fermentation occurs. And fermentation is the result of the activity of bacteria, protozoa, and fungi. Okay, and for fermentation to occur, we need this rumen to be anaerobic, or no oxygen present. And basically what we're going to do through the process of fermentation is we're going to take primarily carbohydrates, and we'll abbreviate carbohydrates CHO, carbohydrates, and we're going to ferment them into volatile fatty acids. Okay, some of the products that come off, in addition to volatile fatty acids, include microbial, crude protein, CO2, and methane. Okay, and when we talk a little bit later about carbohydrates, we'll talk about methane, and methane is a greenhouse gas. So we'd like to try and minimize methane because it is a greenhouse gas and because it decreases energetic efficiency. Okay, so the VFAs are produced here in the rumen, and there are 3 primary VFAs: acetate, 2 is propionate, and 3 is butyrate. Okay, so those are our 3 VFAs, and butyrate's used primarily by the rumen, and propionate and acetate go to the liver. Okay, and so when they're absorbed from the rumen, they're going to go to the liver first. All of the blood in the gastrointestinal tract drains to the liver first. So anything we absorb out of the gastrointestinal tract is going to go to the liver. When we look at acetate, we use a different color for acetate. We should have switched colors a while ago, but acetate will make purple, and we'll just call it acetate, ACE. And we're basically going to release acetate to the peripheral. We'll make propionate blue. And propionate is gluconeogenic, which means you can synthesize glucose from it. Okay, and so what the liver is going to release is glucose. So that's something we need to remember about propionate. Propionate is gluconeogenic, which means can make glucose. Okay, and glucose is real important because it increases marbling. It's required for the brain. Etc. Okay, so in the rumen and the reticulum, we're going to have fermentation. They're going to occur by bacterial, protozoa, and fungi. We're going to produce acetate, propionate, and butyrate, as well as some microbial crude proteins, CO2, and methane. And the VFAs are going to go to the liver, with acetate and propionate primarily going to the liver. Some butyrate will go there as well. The feed, just if you've not seen a cow in real life or seen a gastrointestinal tract, it doesn't actually flow down like this. The abomasum is back over here, but for schematic or for illustrative purposes, it's easier to have it here. So in the abomasum is where we have the production of acid. So HCl is released into the stomach, and the abomasum functions essentially like your stomach. So abomasum equals human stomach, and that we have the production of acid and enzymes. Okay, and the enzyme that we talk the most about is pepsin. Okay, and pepsin's actually secreted as a zymogen, but we're not really going to talk about zymogens, but pepsin is secreted that way. And basically these two, hydrochloric acid and pepsin, are really important for protein digestion. Okay, and from the stomach, or from the abomasum, we're going to move to the small intestine, and we're going to enter the duodenum. And we have secretions coming from the duodenum. They come from the pancreas. And the first secretion is HCO3-, and that's buffer. It's a bicarb. And that's also secreted by the small intestine. And the reason we want to do that is HCO3- increases pH. HCl decreases pH. Okay, and while we're talking about pH real quick, the pH in the rumen is somewhere normally around 6.0 to 6.5, maybe a little higher than that. If you're feeding, you might do all the way up to 7, but pretty common to see the pH around 6.5 is kind of your normal pH with a normal diet. The more concentrate, we'll talk about in a second, the more you're going to decrease that pH. Okay. Another thing entering the small intestine is bile. And bile is stored in the gallbladder and produced in the liver. Okay, and bile is really important for lipid digestion. We're not actually going to talk too much about lipid digestion because we don't normally feed ruminants or beef cattle a lot of lipids, but bile is secreted there. The other thing we have is we have pancreatic enzymes. And pancreatic enzymes are secreted into the small intestine. And then we have enzymes that are also secreted into the small intestine from the small intestine. And for this class, we'll just call those small intestine enzymes. Okay, and so the pH here is somewhere 2 to 3. And then in the small intestine, the pH increases. As we move distally, or as we move down, our pH is going to increase. And we get somewhere close to 6 or 7 in the latter parts of the small intestine. Okay? The small intestine is also where we're going to absorb most things. So we have nutrient absorption. Okay, and those nutrients go to the liver first because, like we said earlier, all the nutrients or all the gastrointestinal tract drains to the liver. And so those nutrients go to the liver, and then they're going to be distributed to the rest of the body. Okay, we have the ileum. Less digestion and absorption occurs in the ileum than in the jejunum and the duodenum. So we have less digestion in here, mainly because it's already all been digested as we move through the duodenum and the jejunum. And then we go into the large intestine. And the large intestine is also a site of fermentation. So any undigested feed residues are going to be fermented in the rumen if they're capable, or in the large intestine if they're capable of being fermented. And what that'll end up producing, as we should know already, is we'll produce VFAs, and those VFAs will be absorbed and go to the liver. Okay, so VFAs, fermentation, large intestine. We also have CO2 being produced, CH4, and MCP, or microbial crude protein. MCP is just a nice acronym for that. So that's like in a few minutes basically how the ruminant digests and absorbs different nutrients. One thing we didn't really talk about is rumination. So up here we'll write rumination. Okay, and rumination is where ruminants get their name from. And basically what the rumination process is the animal is going to regurgitate feed, they're going to re-chew it for a while, and then they're going to re-swallow it. And the reason we like to ruminate or have rumination occur is it decreases particle size, and that results in increased surface area, which increases digestion. Okay, another really important aspect of rumination is it increases pH, and this is the result of HCO3 minus in saliva. Okay, so when the animal ruminates, they chew, 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 and that produces this HCO3 minus, or bicarb, a buffer in the saliva, and that increases pH. And that's important because all these microbes are producing volatile fatty acids, and if we didn't have the production of buffer in the saliva, we would see pH decrease. And it's really interesting, if you put a muzzle on a cow or a sheep so they can't chew their cud or ruminate, the pH of the rumen will go way down because they're not having this buffer being produced. Okay, so that kind of basically in a few minutes summarizes ruminant digestion.